Okay, so the universe is huge, making it hard to figure out its size. Luckily, the James Webb Space Telescope lets us peek way out there. Ever since it started working, scientists like Brian Cox have been sharing cool finds that show just how mind-blowingly big things are. In the bit of the universe we can see, there are about 2 trillion galaxies. That crazy number comes from looking at our local area, but what we see is probably just a tiny bit of what's out there. It's a mystery. We're not just chilling outside the universe, we're part of it. It's like the universe is becoming aware of itself through us. With the Webb telescope, we're on a big trip to find out just how big everything really is. If you want to know about cosmic stuff, subscribe to our channel, like the video, and hit the bell. To put things in perspective, if you drove 70 miles per hour, it would take 15 days to circle the Earth. The Moon is 5 months away at that speed, Mars is 63 years, when it's close, and Neptune is 4,400 years away. That shows you how big our solar system is. Voyager 1, launched in 1977, goes about 38,000 miles per hour. It took 35 years to leave our solar system. Even light, which can circle Earth 7 times in a second, seems slow compared to how big our solar system is. Our solar system is huge, but it's tiny compared to the Milky Way, which has 300 billion stars, each with planets. Our closest star, Alpha Centauri, is 4.3 light-years away. If we went at light speed, it would take 4.3 years to get there. But at Voyager's speed, it would take 70,000 years. That's how far away stars are. Let's zoom in on Betelgeuse, a star 640 light-years away. The radiosphere is how far our radio signals have gone since we started broadcasting, like 100 years ago. They've reached 15,000 star systems so far, though they're getting weak. 15,000 systems is nothing compared to the Milky Way. So when you see Betelgeuse, you're seeing light that left 640 years ago, before Columbus. It's crazy that light has been traveling that long to reach us. Betelgeuse is pretty close, but even crazier is that our radiosphere is tiny compared to the Milky Way. Shrink our solar system to the size of a quarter covering the U.S. That makes the Milky Way the size of Earth. There are 300 billion star systems like ours floating in that space. And it gets crazier. Past our galaxy, there are at least 1 trillion more galaxies. 1 trillion is huge. Imagine 1,000 cats, then 1,000 groups of 1,000 cats, 1,000,000 cats, then multiply 1,000,000 by 1,000,000, that's galaxies. Our closest big galaxy, Andromeda, is 2.5 million light-years away and coming toward us. When Andromeda hits the Milky Way, the stars probably won't crash because space is huge. That shows how big space is and how rare star crashes are, even when galaxies collide. Those crashes might even spread the building blocks for life. Galaxies move and change. Going out from the Milky Way, there's our local group of galaxies, then the Virgo cluster with 1,500 galaxies, and then the Laniakea supercluster with 100,000 galaxies. Each has tons of stars and planets. That's just a bit of the picture. Across the observable universe, there are 10 million superclusters like that. When scientists map galaxies, they only see a little of what's there. Billions are unmapped. Past galaxies, there's cosmic microwave background radiation, the oldest light we can see, left over from the Big Bang. It shows us how the universe was early on. The size of the universe is even wilder past galaxies. There are cosmic voids, huge empty spaces millions of light-years across with hardly anything in them. But they might someday make new galaxies. Then there are cosmic filaments, giant threads of dust, gas, and dark matter stretching billions of light-years, linking galaxies and clusters. They make a cosmic web that gravity holds together, making clusters and superclusters. In this web, galaxies hang out and affect each other with gravity. Space is a huge place with awesome stuff happening. Supernovae are the explosions of dying stars that spread stuff that makes new stars and planets. Black holes have so much gravity that light can't escape, and they shape galaxies. Some shoot out energy across space. Quasars are big black holes eating stuff and blasting out energy, sometimes brighter than galaxies. They're like cosmic lights that let us study the early universe. So, what's past the farthest galaxies we can see? More galaxies, but their light hasn't reached us yet. And because the universe keeps growing, light from some galaxies might never reach us, making them forever unreachable. Scientists think the whole universe is at least 250 times bigger than what we see and might be infinite. It makes you think about what the universe is really like and where we fit in. We're humans on a tiny planet wondering about these big mysteries. Have you thought about how big the universe is? Hopefully, this video helped you get a better idea. Leave your questions in the comments, like to spread the wonder, and subscribe. I'll see you in the next video. Remember, what we know about the universe changes all the time. New stuff like the Webb telescope makes possible what used to be sci-fi. It lets us see the early universe and look at the air around planets, getting us closer to answering, are we alone? Astronomers have found thousands of planets around other stars. Many are in the habitable zone where there could be water and life. Some are like Earth, others are giant gas planets or icy worlds with oceans. There might be billions of these planets in our galaxy, so life-friendly places might be common. But beyond life, the universe has puzzles. Dark matter and dark energy are 95% of everything. Dark matter doesn't shine but has gravity that affects how galaxies move. Dark energy makes the universe grow faster. We know they affect everything, but they're hard to find. Some scientists think there's a multiverse, many universes beyond ours with different rules. They might be separate or in other dimensions, reachable only with math. It's just an idea, but it shows how big we can imagine things. Time is a weird thing in the universe. Einstein's theory says time slows down near big objects. Clocks on a space station near a black hole would tick slower than clocks on Earth. This has been proven and is important for space travel. Speaking of black holes, they're not just cosmic vacuums. They're engines of physics. Almost every big galaxy has a supermassive black hole in the middle, millions or billions of times bigger than the Sun. They change how galaxies grow, control star making, and can shoot energy across galaxies. Even weirder are wormholes, possible shortcuts through space that could connect far parts of the universe or other universes. They're just ideas and would be unstable, but scientists and sci-fi fans like them. In all this, we're a species on a small planet orbiting a normal star in a quiet part of a galaxy with trillions of stars. We're curious, we build tools to explore, and we imagine things beyond what we see. Every picture from telescopes, every radio signal, every tiny particle found helps us learn. So when you look at the night sky, remember those stars are clues to the past, the structure of space, and mysteries waiting to be solved. The universe isn't just huge, it's a mirror showing our curiosity. Despite the size and the mysteries, we're not stopping our search for knowledge. New missions and telescopes will show us even more. Successors to the Webb telescope. Betelgeuse is pretty close on a space scale. Even crazier, our radiosphere, the bubble of human signals, is just a tiny speck in the Milky Way. Think of shrinking our solar system to the size of a quarter on the US. That makes the Milky Way the size of the whole planet. On that planet, there are 300 billion star systems like ours, floating in a massive ocean of stars and planets. But wait, there's more. Beyond our galaxy, there are at least 1 trillion more galaxies. 1 trillion. It's almost impossible to imagine. Think of 1,000 cats, then 1,000 groups of 1,000 cats, 1,000,000 cats, then multiply 1,000,000 by 1,000,000. That's how many galaxies we're talking about. Our closest big galaxy neighbor is Andromeda, 2.5 million light-years away, and it's coming right at us. When it crashes into the Milky Way, the stars probably won't hit each other, space is too big. It is still big. Such crashes could help spread the stuff for life between stars and galaxies. Galaxies are all moving around. Going out from the Milky Way, we hit our local group of galaxies, then the Virgo cluster with over 1,500 galaxies, and then the Laniakea supercluster with 100,000 galaxies. Each one has hundreds of billions of stars and planets. And that's just a small part of the picture. Across the part of the universe we can see, there are about 10 million superclusters like that. When scientists map galaxies, they're only seeing a little bit of what's really there. Hundreds of billions of galaxies haven't been mapped. Beyond the galaxies, there's the cosmic microwave background, the oldest light we can detect. It's leftover heat from the Big Bang, giving us a look at the early universe. But the size of things gets even crazier. Beyond galaxies, there are cosmic voids, huge empty spaces millions of light years across, with almost nothing in them. Those empty voids might burst with new galaxies and future structures. Then there are cosmic filaments, giant streams of dust, gas, and dark matter billions of light years long, linking up galaxies. These filaments weave a cosmic web that holds it all together with gravity. Inside that web, galaxies group together. Space is a huge stage for amazing things. Supernovae, exploding stars, spread the heavy stuff out, which helps new stars and planets form. Black holes warp gravity with extreme physics. Some even shoot out crazy amounts of energy for unimaginable distances. Quasars, giant black holes that are eating stuff and blasting energy, act as cosmic lighthouses, letting us study the early universe. So, what's past the galaxies? Many more galaxies are out there, but their light hasn't gotten to us yet. And because the universe keeps growing, light from some galaxies might never reach us, making them forever out of reach. Based on what we know, scientists think the universe is at least 250 times bigger than what we can see, and might even be endless. This big picture makes you think about what the universe really is and where we fit in. We're humans on a tiny planet, wondering about these massive mysteries and asking big questions. Ever wonder how huge the universe is? Hopefully, this video helped you get a better idea of it. Throw your questions in the comments. Hit like if you liked it, share it to spread the wonder, and subscribe so you don't miss future cosmic trips. Thanks for watching, and I'll see you in the next video. As we keep checking out the universe, remember that what we know keeps changing. New gadgets like the James Webb Telescope have opened doors we only knew through sci-fi. These things are able to see the atmospheres of far-off planets. This brings us a better understanding of what might be the biggest question: are we alone? Astronomers have found thousands of exoplanets circling different stars. Many of these are sitting in spots where water and life could exist. Some are similar to the size and makeup of Earth, but still different. Billions of these planets could mean places for life might be more possible than expected. More than searching for life, the universe itself is full of mysteries. Dark matter and dark energy make up 95% of the universe. Dark matter doesn't let off light, but influences how galaxies form. Dark energy drives the universe and expands on itself. Scientists still don't know how they work or why it's difficult to detect them. Some people suggest that there's a multiverse existing beyond ours. These other universes might be out of reach or are only reachable through math. While it's still a theory, it expands on where we could imagine other universes lying for all we know. Time changes as well. Einstein's relativity shows that time moves closer objects and near the vacuum of black holes could move slow. This has resulted in an experiment and has some impact on understanding travel. Speaking of black holes, they cause change in science. Most big galaxies have black holes that can control star production and can even release extreme energy that can reach different planets. There are even some theories about certain shortcuts connecting universes. We're just common rock and a star that's located at the far reaches of the Milky Way. We're still trying to collect new data and continue to ask different questions. We have the curiosity to build new creations into space and imagine new realities. Space helps us reach our goals through light and radio signal. It helps understand the structure of space and time. There are new mysteries waiting to solved. Remember to look up at these points. You can get a clue to where space is. It's our push to learn and understand what is around. Regardless of the size and mystery, space is something humans will try to understand. Next-generation telescopes will allow more astonishing views. Some future projects will continue to explore moons and help find life. We can analyze the planets in great detail and see new traces. If there is also a way to detect intelligent life somewhere far away, it would change how we understand the role of alien life. There are more AI developing to help process the data from these reaches of space. These technologies help us see and realize what humans cannot see. As we go deeper into understanding the universe, we learn about others, from our history to where we share it with the cosmos. Remember to look up at those stars because they are full of untold stories. Keep your mind open to new possibilities.